All right, these are the essentials you know for the first packet in the exponential unit, which is exponent rules. Okay, so first exponent rule, when you multiply two quantities that have the same base, you add the exponent. So for example, whoops, need to choose a pen. X squared times x to the 7th. The base is the same, it's x and x. So when you multiply these together, you add the exponents together, you get x to the 9th. If you imagined x squared means x times x to the 7th means 7 x's in a row. So how many times do we multiply them all together? 9. Okay, when you divide two quantities that have the same base, you subtract exponents. So for example, x to the 12th divided by x to the 8th. You subtract the exponents and you get x to the 4th. So again, if you imagine you drew out all the x's, there'd be 12 x's in the numerator and 8 x's in the denominator. The 8 x's in the denominator would cancel 8 of the 12 x's in the numerator, and you'd be left over 4. All right, third rule. When you raise an exponent to a power, you multiply the exponent. So here, x squared cubed, you get x to the 6th. Again, the reason here, x squared cubed means x squared times x squared times x squared. Now you're back to rule 1, where you're multiplying the same base, you add the exponents, or if you thought about writing these all out, you'd have 6 x's in a row. All right, so those are the 3 basic exponent rules. So here's an example problem where we're going to use these rules in combination. Okay, so the first thing I'm going to do is square this parentheses. So this 2, the biggest mistake people make here is they forget to apply that exponent to the 3. So in the numerator, you should have 9. So then x, I have an exponent being raised to a power, x to the 6th, y to the 14th, times 2x to the 4th, all over y to the 10th. Now I'm going to multiply the two quantities in the numerator together. First, the numbers, 9 times 2 is 18. X to the 6th times x to the 4th. So same bases here. So we're going to add the exponents together. You get x to the 10th. Y to the 14th. All over y to the 10th. And then to finish the problem, we have division with the same base. So we've got y up here and y down here, and we're dividing. So we're going to subtract the exponents. So you get 18x to the 10th, y to the 4th. And all of the y's in the denominator canceled out. So this is the answer. All right, the next type of exponent you'll see in this unit are negative exponents. If you see a negative exponent, it means that you need to take the reciprocal of the base. So 2 is the base. We take the reciprocal of the base and then apply the exponent. So we're going to flip the base and then cube it. So 2 to the negative 3 is the same thing as 1/2 to the positive 3. So that's the part where I flipped the base, took the reciprocal, and now we're going to cube it. 1/2 cubed is 1/8. If the base starts in the denominator and it has a negative exponent, you can just flip it to the numerator and make the exponent positive. And now there's just a 1 left in the denominator. So this is going to be 16. So negative exponent means flip and then raise. Okay, so here's another example. The exponents that are negative, I'm going to flip them to the other side of the fraction bar to make them positive. So this 2 to the negative 4th, I'm going to put that in the denominator. Now it's 2 to the positive 4th. The 3 cubed already had a positive exponent, so I'm just going to leave it where it was. And then down here I've got a 5 to the negative 2. Well, I'm going to move the 5 to the numerator, and now it's 5 to the positive 2. So that's 25 times 27 all over 16. If you needed to, you could use a calculator to figure out the answer to that, but I'm not going to go any further simplifying that. Okay, here's some negative exponents with some variables. So I look at there. First, I want to say that there's a lot of different ways you can do this problem. You can do things in a different order than I'm doing them in here, but this is just how I'm going to do it. So I see that there's a negative 2 exponent on the outside here. To make that positive, so the base to that exponent of negative 2 is everything in the parentheses. So what I'm going to do is I'm just going to flip the entire fraction inside the parentheses. So now x to the negative 2 over x to the negative 4th y cubed. And then the exponent on the outside now is going to be positive 2. So I've taken care of the flip the base part of that negative exponent. Now I'm going to deal with the stuff inside the parentheses. I've got some negative exponents in there. Okay. So up here, this x to the negative 2, I'm going to move that down so to make its exponent positive. And then the x to the negative 4th, I'm going to move up to make its exponent positive. So now I have x to the positive 4th in the numerator and x to the positive 2 in the denominator. The exponent on the y was already positive, so it's not going to move. It's just going to stay where it was, and the whole thing is still squared. Okay, now I can use the same base and division rule here because I have x over x, so I can subtract the exponents. So you have x squared over y cubed, still the whole thing squared. Now I'm going to use when you raise a power to another exponent, you multiply. In the numerator, x squared squared is going to give you x to the 4th. In the denominator, y cubed squared is going to give you x to the 6th. Or sorry, y to the 6th. And that's the answer. Okay, the last type of exponent you're going to see in this unit are fractional exponents. Fractional exponents are another way to write a root. So fractional exponents mean roots. And the root you're taking is always the denominator of the fraction. So for example here, it says the exponent 1/2 is the same thing as square root. Exponent of 1/5 means the 5th root. The number that we write in here next to the root that tells you which root you're taking is called the index. So the denominator of the fraction tells you the index of the root that you're taking. All right, so how do you actually do some of the problems? Okay, so 16 to the 1/2. That means the same thing as the square root of 16. Most people already know that this is 4, but just to show you why, 16 is 4 times 4. Since we're taking the square root, we're looking for matching pairs to come out of the radical, and 4 does. The next example problem, the 5th root of 32x to the 10th. So to simplify the number 32, I'm going to factor it. Spoiler alert, it's 2 times 2 times 2 is 2, x to the 10th. Since we're doing the 5th root, we're looking for 5 of a kind. Coincidentally, there are 5 2's, so a 2 can come out of the radical. And then we have x to the 10th. You can imagine if you wrote out 10 x's, we're looking for 5's of a kind. So every time there are 5 x's, we can pull one of them out. Since there are 10 x's under the radical and we're looking for 5, there are going to be 2 sets of 5 that can come out. So you're going to get 2x squared when you pull out the x's. A shortcut way to think about that is you divide the exponent on the variable by the index, and that tells you the exponent is going to be on the variable outside. Okay, next problem. 1/3 power means cube root. Okay, so when we factor 16, it's 4 2's. Okay, so there's a 3 of a kind of 2's that can come out, so we're definitely going to have a 2 that comes out here. But then a 2 was left behind because there were 4 2's in there, so one of the 2's is stranded inside the radical. And then we have x to the 10th, y to the 12th. Okay, so like I said in the previous example, to figure out the exponent on the variables, we can take the index and divide it into the exponents, right? The y is the easier one here, right? 3 goes into 12 4 times, so that means on the outside we're going to have a y to the 4th. 3 goes into 10 3 times, because 3 times 3 is 9, so we're going to have an x cubed out here. But there's still going to be one x left over. If you imagine writing out all 10 of the x's and you're looking for groups of 3, there are going to be 3 groups of 3 x's that you can pull out, but there'll be 1 left behind stranded, just like there was a 2 left behind. So this would be the final answer. Okay, here's some practice problems. It would be really good for you to pause right now and try these on your own, and then see if you get the answers right. I'm going to pause the, I'll just do them out. Okay, so problem 1, 1/3 power is cube root. Okay, let's try to take care of the negative exponents that are in here. So the x to the negative 10th I'm going to put in the denominator, and the y to the negative 4th I'm going to bring up to the numerator. 125 stays where it is. I'm going to get y to the 10th in the numerator. And then 16, I'm going to get x to the 12th in the denominator once I move the x to the negative 10th down. Okay. Okay, so we can bring a 5 out. I'm looking at how to simplify the y to the 10th. 3 goes into 10 3 times. So we're going to have a y cubed on the outside, and then cube root of y. There's going to be one y left in the radical. All 3 of the 5s came out. In the denominator, we are going to have one triplet of 2's that can come out of the radical. And then 3 goes into 12. So I'm looking at the exponent on the x. 3 goes into 12 4 times, so we're going to have x to the 4th. And then cube root of 2. One of the 2's was left behind. And then the next one. So again, I'm just going to go ahead and apply the exponents. Remember that when there are numbers inside the parentheses, you have to apply the exponent to them too. So 2 to the 4th is 16, c to the 12th, d to the negative 20th. Using raising exponent to a power, you multiply. And then 4 cubed is 64. C to the 30th. D to the 6th. Okay. So we can just start simplifying. 16 goes into 64. I want to say 4 times. Double check. I'm correct. When you deal with the c's, you can imagine there are 12 c's in the numerator and 30 c's in the denominator. So all of the 12 c's that are in the numerator are going to cancel with the c's in the denominator. So you're going to have c to the 18th. And then there's a d to the negative 20th up here. To make that exponent positive, I'm going to bring it down to the denominator. There was already a d to the 6th down here, so now there's going to be a d to the 20th as well. Everything from the numerator has canceled or moved to the denominator, so that means there's just a 1 left behind. And then the very last thing we have to do is combine the d's. D to the 26th. And there you go. All right, that's it.